Okay, our last topic for our probability unit is going to be permutations and combinations. Permutations and combinations are just a way of counting objects or counting how many ways things can happen. In a combination, the order of the objects or the order things happen does not matter. So in a combination, the order does not matter. Okay, therefore, the other way of thinking about it is in a permutation, the order does matter. Okay, so let's take a look at some examples of things you'd maybe need to order or choose combinations of things and things like that. So let's think about whether the order matters or not, remembering that order doesn't matter with a combination, but it does matter with a permutation. So alphabetizing, okay, alphabetizing is, I would think, kind of an obvious one because alphabetizing definitely indicates that there's an order. So in alphabetizing something, anytime you're putting in an alphabetical order, that means it'd be a permutation, so the order does matter. Okay, putting toppings on an ice cream cone. Now, while I know some of you have a preference in the order that you put the toppings on an ice cream cone, ultimately the order that you do it does not really matter. So that's going to be a combination. Same thing with a fruit salad. Doesn't matter if you cut the carrots, if you cut the strawberries before you do the grapes or anything like that. So the order for making a fruit salad doesn't really matter either. Now, when you go to open your lock, a combination on a lock, well, you have to put that combination in a specific order, so that would be a permutation. The order that you put that number in has a specific order it needs to be in. A license plate that has 3 numbers, then 3 letters, since it says 3 numbers have to come first, then 3 letters, that means that it would be a combination. I'm sorry, since it has an order that it has to be the numbers and then letters, means it's not a combination, it's actually a permutation. I apologize. You are just randomly choosing a group of 4 people to be on your team for PE. The order is random, so it doesn't really matter, so that would be a combination. You are awarding first, second, third place in a race. Anytime you are ordering them first, second, third, or giving jobs to someone, this job specifically, this job specifically, this job specifically, that would mean that the order matters, so you'd have a permutation. And then the last thing, you're just randomly picking 5 pairs of shoes from your closet to take on vacation. The order that you choose them doesn't matter, so that would be a combination. So anytime you're thinking, should I use permutation or combination, just ask yourself, does the order matter? Okay, so again, combinations, when we have combinations, the order doesn't matter, does not matter. And when we calculate calculate combinations, you're going to use your yellow calculator. So again, a lot of things that we're going to be able to do on our calculator. And the first thing it's going to ask for is there's 2 variables you have to know, N and R, okay? N is the total number of objects or opportunities, things like that, that you have to choose from. And then R represents how many you're actually choosing. Okay, in your calculator, okay, on your TI-84, the yellow calculators that we use, you hit all good things come from the math button, arrow over to the probability, and then you'll notice that it'll bring up a screen, and the third option down will have a C with an N and an R. Okay, so an example here, an ice cream shop allows you to choose 2 toppings from their list of 11. How many ways could you choose 2 toppings? Doesn't matter the order that you choose the toppings in to put them on. So this is going to be a combination. So no, it does not matter. So it's going to be a combination. Okay. So in your calculator, you're going to go, again, math, probability, C, N, R, and you're going to put it in just like this. So you'd put that there was 11 total options, and you're choosing 2. Once you get that in there, you just hit enter, and you should have, let's see, 55 different ways that you could make an ice cream cone with 2 toppings when you choose them out of a list of 11. Okay. Similarly, exact same thing except with permutations. Again, remember that when you have permutations, the order does matter. So order matters, just reminding you of that. And again, N is your total, and R is how many you're choosing. Okay, so in your calculator this time, you're going to hit the math button, arrow over to probability. This time you see there's the option number 2 was the P with the N and the R. And so that's the way you're going to use a permutation as opposed to a combination. P for permutation, C for combination. So in a horse race, you're awarding first, second, and third. You're ordering them in places, which means since you are ordering them, that it's a permutation. So the order matters. So it's a permutation. Okay, so in your calculator, you would use your permutation button. You had a total of 10 horses racing, and you are going with the top 3. So you have 10, choose 3. And when you go ahead and put that in your calculator, let's see what we get. So there would be 720 different ways that those 10 horses could place if you're placing them first, second, then third. Okay. Last but not least, let's just do a couple of examples mixed together here and decide if we're using permutations or combinations. You're making a 5-layer cake, and each layer needs to be a different color, okay? If he has 12 colors to choose from, how many different layered cakes could he have? Well, since each one has to be a different color, the order you put them in matters because you can't have the same color twice, which means if the order matters, that means that it is a permutation. So we would have P, and we had 12 to choose from. And we are picking 5 of the colors. Okay, so we have a permutation where there's 12 colors to pick from, and we're picking 5 of them. And if you do 12, choose 5 in your calculator, you would get 95,040 different ways that you could make 95,000 plus cakes that you could make. Okay. James is planning a trip for him and his friends. They have 7 cities in the Midwest they want to visit, but only have time to visit 3 of them. So since they are going on a trip and they have to go in a specific order, they can't go back to a place they've already been. The order that they go to matters. So therefore, it is a permutation. Okay. Also think about if you're taking a trip or something like that around the Midwest, you wouldn't go from Iowa over to North Dakota and then back to Nebraska and then down to Kansas. You'd go in an order that would make sense so that you're minimizing the amount of travel that you're doing. So it's a permutation. So we have a permutation, and you have 7 and you're choosing 3, which means permutation of 7 chooses 3. There are 210 different trips that you could take if you wanted to choose 3 cities to visit. Okay. Next one, you got the Crayola Company is making a specialty box of crayons to sell for Valentine's Day. They have 45 color options to choose from, but in their specialty box, they can only put 8. Okay, they're not 8 specific colors. They're not picking, just because it's Valentine's Day does not necessarily mean they're picking pinks and reds. It's just 8 random crayons can fit into this box, and which means the order would not matter. And if the order does not matter, that makes it a combination. So we'd have a combination of 45, choosing 8 of them. And that's a lot of different boxes of crayons that they could make. They would have 215,553,195 different ways that they could make boxes of these 8 crayons. And then finally, you have a group of 9 friends that all want to go to a concert, but they only have 5 tickets. And you're just randomly picking 5 of your friends to go with you. Since just randomly picking them, order doesn't matter, so it would be a combination. So you'd have a combination of 9, and you're choosing 5 of them to go. If you put a combination of 9, choose 5, you'd have 126 different combinations of friends that you could go with. So once you're done with this, there is a permutations and combinations class kick that you need to complete.